we'll be solving this question of detecting a cycle in an undirected graph. Last time we used a DFS and this time we'll be using a BFS. So let's start. We'll declare a queue first of the name queue, and then no, we won't declare this here. We'll just use a helper function. So for int I is equal to 0, I is less than b, I plus plus, if we are using BFS, just BFS of, and we call it only if it's not visited here. So we'll write this as if not visited. For that we need a visited array, right? So we'll declare a visited array here. So we'll declare a visited array vector in was v comma false, and one more array parent vector int parent v. Okay, if not visited, then we if BFS of I, since it's not visited, and will pass visited parent and joint adjacent is equal to true, means if the BFS function returns true, that it contains a cycle, will return a true, and at the very end, if there are no cycles, then we return a false. Now let's code the BFS function. Private bool BFS int source vector int ampersand visited vector int ampersand parent vector int join. Okay, now mark visited of source is equal to true, and parent of source, right now it has no parent, so -1, and we'll declare a queue as well. Queue int queue, and we'll push this to the source, right? And now while not queue dot empty, while not with an int node is equal to queue dot friend queue dot for or row ampersand child of the node, child or an adjacency nodes of this node. If it's not visited, then to we make it visited of adjacency nodes is equal to true, and we'll mark the parent of this adjacent node as node, right? So we'll make it singular node because we're dealing one node at a time. So it's, if we declare it singularly, and parent of node is what? Node, because this is the adjacency of adjacent node of this node, and parent of this adjacent node is this node, and then we'll push this to the queue adjacent node. Else, if it's not visited, like in BFS, we'll check. The only case it's, for example, for 2 we have to, the parent of 2 is 1. For example, we are starting from 1 to 2. Now at this point in time, at 2, we'll check what are the adjacent nodes of 2, which is 1 and 3. Now since we're coming from 1, there can be a possibility that this adjacent node is visited, right? So not visited of adjacent node, right? If this is visited, means the only case we can arguably tell that it's fine that it's visited is when this is the parent, right? So we'll check if the parent of the current node that we are at, are you the parent? Else if the parent, are you not the parent? Adjacent, we have to check for the false cases. If the adjacent node is not the parent, we return false, else we return. Simple. I guess this should be fine. Not visited. Okay, fine, not visited enough. I here q comma q dot off. Okay, so we are having it false, so let's see what's the problem. Visited source is true, parent of source is -1 at this point in time. Okay, q dot push source and node is equal to q dot front, q dot path for if not visited of adjacent node means visited of adjacent node is true, parent of adjacent node is node itself, q dot push is adjacent of node, else if parent of node is not equal to return false. Return true, right? I mean, this will mean that it has this will mean that it has that cycle, else return false. Yeah, because you're checking for the two cases. False cases will be the all the other cases. So for a limited case we check for the limited possibilities, right? So for true we check, and for false it's all the other possibilities. Now we'll submit this. It works. I hope you would have understood. Thank you. Now there can be one doubt, why are we using this extra array? This just for the simplicity of code. You can use q of pair also, but it's good that you have a parent array. For example, if the problem is a little big, so it's better to not pass q from function to function and then check the second part of the queue. I mean, that essentially takes the same space because that is a queue of pair, so it will take 2 into v space, and here we are taking two different arrays of v space each. So ultimately the space complexity is same. I mean, order wise it is already same, but like, even the space wise it's exactly 2v in both the cases. So it's not that since we're using queue of pairs, that's a what do you say,